Hello everyone. This is Vahita from CS Department of Rohini College of Engineering and Technology. I am here to discuss a few topics about the subject CS 3352 Foundations of Data Science. First, let us see about the benefits and uses of data science and the facets of data. Before that, we have to learn what is data. Data is measurable units of information gathered or captured from activity of people, places and things. So data science is an interdisciplinary field that seeks to extract the knowledge or insights from various forms of data. So at the core, the data science aims to discover and extract the actionable knowledge from the data that can be used to make sound business decisions and predictions. So it combines both the maths and statistics along with specialized programming, advanced analytics, artificial intelligence and machine learning with specific subject matter expertise to uncover the actionable insights hidden in the organization's data. So this data science has some life cycles which has capture, maintain, process, analyze and then communicate. In the case of capture, we have data acquisition, data entry, signal reception and data extraction. These are the things how we extract a data or how we captured a data. Then maintain is how we are going to store it and maintain it. That is data warehousing, data cleansing, data staging, data processing and data architecture. The process is done by the data mining, clustering and classification, data modeling and data summarization. Analyzing part has the data reporting, data visualization, business intelligence and decision making. Then communication comes under exploratory and confirmatory analysis, predictive analysis, regression, text mining and qualitative analysis. So now let us see what is big data. Big data is a blanket term for any collection of data sets so large or complex that it becomes difficult to process them using traditional data management techniques such as, for example, the DBMS, that is Relational Database Management Systems, also comes under this big data process. Okay, so characteristics of big data. We have three characteristics, that is volume, variety and velocity. So volume is how much data is there. Variety comes under how diverse and different types of data are available in that. Then velocity comes at how much speed the data is generated. So these are the main characteristics of big data. Now let us see how about the data science is proceeding. Data science involves using methods to analyze massive amounts of data and extract the knowledge it contains. And data science and big data evolved from statistics and traditional data management but are now considered to be distinct disciplines. It is an evolutionary extension of statistics capable of dealing with massive amounts of data produced today. The benefits and uses of data science. Data science and big data are used almost everywhere in both commercial and non-commercial settings. So commercial companies is almost every industry use data science and big data to gain the insights into their customers, processes, staff, completion and products. Governmental organizations are also aware of data's value. Many governmental organizations are now rely on the internal data scientists to discover valuable information but also share their data with the public. Non-governmental organizations, that is NGOs, use the data to raise money and defend their causes. The World Wildlife Fund, that is WWF, for instance, employs the data scientists to increase the effectiveness of their fundraising efforts. Universities use the data science in their research but also to enhance the study experience of their students. Now let us see about the facets of data. The data science and big data will come across many different types of data and each of them tends to require different tools and techniques. The main categories of data are structured, unstructured, natural language, machine generated, graph based, audio, video and images and streaming. So these are the categories of data. First, let us see about structured data. Structured data is the data that depends on a data model and resides in a fixed field within a record. It is easy to store the structured data in tables within the databases or Excel files as shown in the figure like this. This is an Excel file which has a data. Then let us see about unstructured data. Unstructured data is a data that isn't easy to fit into a data model because the content is context specific or varying. One example of unstructured data is the regular email as shown in the figure. Now let us see about natural language. Natural language is a special type of unstructured data. It's challenging to process because it requires knowledge about a specific data science technique and linguistics. The natural language processing community has had success in entity recognition, topic recognition, summarization, text completion, and sentiment analysis. But models trained in one domain don't generalize well to other domains. Machine generated data. The machine generated data is information that is automatically created by the computer process, application, or any other machine without human intervention. The machine generated data is becoming a major data resource and will continue to do so. IDC, that is International Data Corporation, has estimated that there will be 26 times more connected things than people in 2020. This network is commonly referred to as the Internet of Things. Graph-based or network data. In graph theory, a graph is a mathematical structure to model pairwise relationships between objects. Graph or network data is the data that focuses on the relationship or adjacency of the objects. The graph structures use the nodes, edges, and properties to represent and store graphical data. So this is a diagram which shows a graph. Now, audio, image, and video. Audio, image, and video are the data types that pose specific challenges to a data scientist. Tasks that are trivial for humans, such as recognition of the objects in pictures, turn out to be challenging for the computers. In game analytics, the high-speed cameras or at the stadiums will capture the ball and athlete movements to calculate in real time. For example, the path taken by a defender relative to the two baselines. Now the streaming data. While streaming data can take almost any of the previous forms, that it has an extra property, that is the data flows into a system when an event happens instead of being loaded into a data store in a batch. So although this isn't really a different type of data, we treat here as such because we need to adapt our process to deal with this type of information. Thank you.